Hello everyone and welcome back. So in today's video we will start a new project on the channel, basically creating these favela-like buildings in Bifrost. So we can set the amount of iterations, we can play with the seeds and get different variations, and everything will adapt. As you can see, the pillars, the windows, the doors, position, and the good thing is that everything can adapt, so it's procedural. And if I get positive feedback in this one, maybe we can take this further. So today we will start simple and just do the stacking of the buildings, and we will go from there. So yeah, let's get into it. So just a quick note before we get started. I'm going to be using a custom compound that I made, but you can find a very similar one and probably even better on the Bifrost the Discord server by Andrew. And you can find these recursive subdivisions and you can use that one instead. I'm going to use my own. You can grab my own on my Patreon, but feel free to use instead this one. So let's open the Bifrost graph editor and create a new one. I'm going to delete the input and output, create a terminal, and I'm going to create also the initial plane. So plane, let's see, create mesh plane. I'm going to connect it to the proxy, and here is our plane. I don't want any initial subdivision, so I'm going to set this to 1 and 1. Let's disable the grid and also enable this anti-aliasing, multi-sampling. And length of 1 and 1, I don't need UVs, that's fine. And now, we want the idea for today is to do the stacking of the buildings. And for that, we need to take into consideration the height of the last layer. So instead of a for loop, default for loop, we will need an iterate loop. So that way we know the previous iteration. We have access to the previous iteration. I'm gonna connect the plane into here and go inside and connect this to the output and make it iteration target so we can iterate over each one. And I'm gonna connect it in here. For now, I'm gonna set the max iterations to 1. And let's call this stack v1. So that's fine. Now, inside, well, let me see. First of all, we want to subdivide this mesh with that recursive subdivision. So I'm gonna use my own. Feel free to use the one from Andrew. So as you can see, let me set the wireframe. We subdivide this into different sections. It's like the lot subdivisions in Houdini. In this case, I'm gonna use just 2 iterations. You can play with the seed and you can play with the bias to have more or less effect. As you can see, I'm gonna leave it like that because we will change that in a bit. So now after this, I'm gonna create here just a null, which is a pass in Bifrost. And I want just to keep these middle faces. So middle faces, yeah, in Maya is faces. No, I can't select. So in order to keep them, I will measure the distance of the centroids of each face from the center. So this is at 0, 0, 0, as you can see. And delete any faces that are further than a specified distance. So this will make more sense if we actually do it. So let's do update face centers so we get that information, and we will measure the distance. So distance between the face center and the 0, 0, 0, so the center of the world. That's fine. And now we will do a less if that distance is less than, let's say, let's create a value in here. So create value node and let's say 0.35. And if that is less than 0.35, we will find all true in array. Find all true in array. So this way we get the indices of the faces, and we can simply filter faces. So if we connect this to the mesh and this to the indices, as you can see, we can play in here with the distance, and we can delete them based on the distance from the center. So hopefully that makes sense. I'm just going to select these nodes, Control G, and let's say dist from center. And I'm gonna dive inside, organize this a bit, and connect this distance in here. And let's rename this to dist. So that's one thing done. Now from here, we want to extrude So after the filter faces, we will extrude the faces. So extrude faces. Let's connect these in here. And this by default will be way too much. So let's set this thickness to like 0.2 or something. So that's fine. Let's save. And now is the time where we start to stack this. So if I come in here and play with the max iteration, as you can see, we'll always have the same result. So we need to do something in here. We need to transform this. So let's do a transform point, not transport, transform points. Transform points. Oh, there you are. So now in order to do that, we need to calculate the height of each layer. So let's do that actually. So let me see if I can make this in a way that makes actual sense. So I'm gonna connect these in here and this to the output. So I'm gonna create in here, I'm gonna get the point position. So get point position of the current input. I'm gonna split that from a vector to a scalar to get the y component. And from the y component, which is the height, the y position, I mean, I can get the array bounds. So this way I get the minimum y position and the maximum y position. And I'm gonna connect that to the output, so max bound. And let's see if I connect now this in here. So if I do a vector to float, let me see in here. I need to do a scalar to vector, so scalar to vector. And I'm gonna connect the y component in here and set these port states to the max bound. So I'm connecting it to the last iteration. And now I can take that and feed it to this transform. So let's do SRT2 matrix, which is just a visual representation or a better interface for dealing with matrices. So this transform points only accepts matrix 4. So we are doing this step in between scale, rotation, and transform to matrix. So this way we can feed more easy, not more easy values, but more approachable values, let's say. So I'm gonna set these on, so x and z to 0. I'm gonna feed this to the translation and this to the transform. So let's see if we increase the iterations. Now we should have a stacking of the building. So we're taking the last iteration and transforming by the amount of the last height. And now we will do a random thickness of each layer, and it will work the same way. So if we come in here into the extrude faces, we have here a thickness, and we can take the current index. So this way we have a single value for each iteration, and we will add a seed. So I'm going to connect these in here and change the name to low. Let's just say change it to seed. So now I have a way to changing the seeds. And for the random extrusion or the thickness, I'm gonna create here a random value, and I'm gonna take this as a seed. And between, let's say, the mean can be 1.16 and the max 0.26. Let's say something like that. And I can feed this to the thickness. And let's see, it didn't change much, did it? So I can play with the seed, and as you can see, we will have a random. I can go more extreme, and we can play with the seed, and everything will adapt. And if I change the max iteration, as you can see, it will always adapt. So I pressed W, but it's not W, it's 4 in Maya, but you can see much. So now we need to change also the scale along Y and the rotation to have these working. So let's do that next. So before we start with the scaling, the scaling along Y and the random rotation, I want to change something in here because right now we have always the same pattern. So if we actually change the seed on these recursive subdivisions, we can feed that to our global seed. So, and now we have a different pattern for each iteration. And let's see, we can play with the iterations and play with the seed, and that is fine. So now let's say we want to reduce the scale along the Y. So we have that current index. And if we take the current index and change the range, so let's see, change range, this is just like a fit function in Houdini, and we take as a value the current index, so, and I need to translate this to a float, so to float, that's fine. And now we take again a to float, but to the max iterations, and we feed that to the from start. And we can say in here, let's say 0.9 and 1.2, maybe 0.6 in here. And we feed this into the scale. But in this case, vector to float, vector to scalar, vector to scalar. No, scalar to vector, I mean scalar to vector 3. And I just want to change the scale along X and Z and keep the Y at 1 because I don't want to change the thickness. And if I go in here and feed this to the scale, as you can see, it will scale along Y. And I can come in here and change how much it will scale down. And you can enter some randomization. Oops, now it's too much. Let's just keep this at 1 and change this in here. So that's another step done. Now we need to play with the random rotation. So I'm gonna complicate things a bit in here, but you can totally just feed a random value to the quaternion in here with the necessary conversion nodes, and it will be all right. But again, I'm gonna complicate it a bit so we can possibly learn something new. So first of all, we'll start with a random value. So random value. And I just want, I want a random value based on the seed. So we'll go in here. And I want a random value between 0 and 1. That's fine. Now I want to do, if I connect this, maybe it will be all right if we connect this to the necessary conversion nodes, which will be the degrees, because we will play with the degrees to be easier. So I'm going to change this to degrees, to radians, and then I just want to rotate along Y, so I'm going to do scalar to vector 3, and I'm just going to change the Y, and finally we need to convert the Euler to quaternion, since the SRT2 matrix only accepts quaternion, so I need to fit this in here. Is that working? So let me see, let me organize this a bit. And if I change in here the mean to, let's say, 0 and 60, we should have a, so you already have a random rotation. But I'm gonna complicate this a bit. So instead I want to have extreme angle. So let's say I have a max angle of 15 and I want values closer to 15 and minus 15. So we get a more random look. This is already pretty good, but we can play a bit more with this. So let's do instead between 0 and 1. And now I want to transform these values to make these values zero-centered, so between negative and positive values. So for that, I'm going to multiply by a value which will be 2 and subtract 1. This is a common math operation to do zero-centered offsets. So this is always good to know. And I'm gonna take this and feed it in here, and also copy this, Control G, zero-centered. So that's fine. Now, this now has positive and negative values. Let's actually put them in here. So as you can see, we have positive and negative values. So in order to bias the angle towards the ends, we need to do a bit of a setup in here. First, we need a max angle, so I'm gonna create a value node and name it in here max angle. You don't need to do this, I'm just trying to organize this a bit, and I'm gonna say 15. So I want to have values between 15 and minus 15. So that's the max angle, and we have the zero and centered offset. Now I'm gonna take from the zero centered random value, I'm gonna take the absolute value, so make them positive again. And I'm going to do a power function so I can bias the values, and this will be the base, and the exponent will be how much we bias. So let's say 0.9. Values between 0 and 1 will work fine. And now I'm going to, from these zero centered, I'm gonna get the sign, so copy sign. So the sign will output -1 or 1 in this case. I'm gonna take this as a sign input, and we can say 1 or -1 in here. So now I'm going to multiply this operation in here, so the power, by this sign, so to make the values negative, and again, not negative only, but positive and negative, because right now they are only positive. And finally, we can just take the max angle. This should be bigger so you can see it better. And finally, I can take the max angle and multiply it by this operation. So now it will just scale the angle to these values. And if I feed that to the Y, as you can see, we have a more controlled look, and you can play. What is this thing doing in here? Oh, I need to change in here. So Euler to quaternion, I need to change in here this. So now it's working. So just 15 degrees. So as you can see, I can play with the amount. I'm gonna set it to 15, and I can also go to the bias and bias towards the value I want. So -15 or 15. I'm gonna keep it like this, and we can play with the seed, and as you can see, we will have a more randomized look. I hope this makes sense. This is a setup that I recently learned to do these biased angles, and it's still new to me. And I haven't played with Bifrost in a while, so I'm trying my best in here. Hope you understand that. So maybe let's take this and Control G and do random angles or random rotation. And let me see, I don't think I'm missing anything in here, so I did the random rotation. And yeah, guys, I think we reached the end for today. So let's test our setup. Now we can obviously feed the interface to here, so let's actually do that. Let's we don't need this, but maybe we need the distance. And let's see, what else do we need? We have the seeds, so let's see, in the random rotation, so scale mean, let's rename this scale y mean, copy, and connect this one and do scale y max. Save, and we also have the random rotation. Where is that? So it's in here. Let's change this in here to the max angle. Oh, where is the input? It's here. So let's rename this max angle. And we could possibly feed in the bias, but I'm not going to worry about that. And let's feed this to our main compound. And let's see, let's play with this. So I'm gonna get this and remove from here. And now we should be able to play with the iterations. We should be able to change the scale mean and scale max. And play with the seed. We could possibly introduce a new seed for the height of each layer. And we can play with the distance. We can make it shorter. And yeah, that's basically it. We can play with the max angle and play again with the seed. And we get, so now the distance is too big, so we need to reduce it. And yeah, guys, this was basically it for today. Hopefully you got something out of this. This is just like a random tutorial that I decided to make because I have this project in here for a while and I decided to share it with the world. And for the Houdini guys that follow my channel, don't worry, I will be back to Houdini pretty soon. And if you are curious, this setup was actually taken from Houdini and I just adapted to Bifrost. So if you want me to cover this in Houdini, I can also do so. Let me know in the comments. As always, you can grab the files on my Patreon, alongside with exclusive tutorials and all the project files from my videos. So let me know in the comments if you want me to continue this series. And yeah, thank you for watching, and I'll see you next time.